All right, so we have Know Your Chances worksheet next in the class, and we're just going to cover the first page in this worksheet. Um, after um, after this first bit on death rates, the worksheet goes into some things on climate change, which is great information to read over, but I don't for time's sake and for our class, I don't think it's necessary, but you can certainly work through that if you'd like. Right, so we're just going to focus on this first part because I want to make sure you know how to read a table like this. You will have some problems in your homework that have a similar type of table. Right, so we're given this table of death rates, and this is from a reliable source, right? It's from the Journal of the National Cancer Institute, right? So listed here, right? We're told where the data came from. So what we have some death rates, and these are deaths per 100,000 people for age 55 years old, and we followed them for over the next 10 years, right? So like for example, this number here, right, represents a 55-year-old male who smokes. So this tells me that three out of 1,000 males age 55 that are smokers died in colon cancer within 10 years, right? So these numbers are death rates, right? So number one, it asks us who is more likely to die in the next 10 years from a heart attack, a 55-year-old man or woman? And notice it doesn't specify smoking, right? So let's compare. So if we look at male who never smoked, right, 19 out of 1,000 will die of a heart attack, right? If we compare that to females who never smoked, only 8, right? So just looking at the never smoke, the males have a higher rate, right? And then if we compare to smokers, so the male smoker has 41 and the female smoker only has 20. So the males have a higher rate again, right? So we don't need to specify smoking or not because the males win in both cases, right? So we could say the 55-year-old man is more likely to die from a heart attack in the next 10 years. Right? So we could say this is regardless of their smoking status. Right? So if a man smokes or not, they're more likely to die from a heart attack, right, than a female. Right? So number 2 says, by what factor does smoking increase the chance of a 55-year-old man from dying from lung cancer, and also for women, right? So if we look up here, so we're looking for lung cancer, right? So here, right, these values. So between the males from non-smoking and smoking, this increased times 34, right? 1 times 34 is 34. And then with the female, this increased by a factor of 13, right? 2 times 13 is 26. So we could come down here and say something along this effect, right? So make sure we have some large font. So we could say for men, the risk of dying increases from 1 in 1,000 to 34 in 1,000. So by a factor of 34. So we could say for women, the rate increases from 2 to 26, so by a factor of 13. Right? We could say something along those effects. And then number 3 asks, does smoking cause heart attacks, or does it minimize the chances of getting breast cancer? Right? So if we come up here, if we're trying to see if smoking causes heart attacks, right? What they're trying to get us to notice. Let me do some erasing here, right? So clear this table. Right? So the first question is considering heart attacks, right? So noticing that if you're a male and you smoke, your risk of heart attack increases, right? And same with the female, right? The smoking, if you know someone that smokes is more likely to die from heart attack than someone who doesn't smoke, right? Based on this data, this table, right? So the question is, does smoking cause heart attacks, right? So something that we need to be able to conclude, and lots of times, people want to say that, oh, well, this data shows that smoking causes heart attacks, right? But we don't know that actually happens, right? Because this is just an observational study, right? So we can't say just because these appear to be correlated that we have causation, right? So the correct thing to say here is something about like this table is observational and does not indicate causation, right? So we don't know if there are other factors going on, right? So for example, maybe smokers have a poor diet and don't exercise. Which may be the cause of heart attacks. Right? So in other words, just because someone smokes doesn't necessarily mean they're going to increase the rate of a heart attack, right? Maybe someone who smokes and has a great diet and exercises regularly, maybe they don't have a high rate of getting a heart attack, right? So we can't just say this based on this data, right? We can say that it appears that smoking seems to have some type of influence on heart attacks, right? They seem to be somewhat related, right? But we can't say for certain that smoking causes heart attacks, right? An increase in heart attacks. The only way to know for sure is we this is an observational study. What we would need to do is conduct a controlled experiment, right? So a controlled experiment is just like in science class where you study, for example, you could study, different people, two different groups of people, and you have to keep everything the same, right? So the diet and exercise regimen and so forth would be the same between our two groups, right? So here, let me true this. So in other words, here we have two groups. So over here, maybe we have smokers. And over here, we have non-smokers. Right? So we would need to keep all other factors the same, right? So diet, exercise, etc. Right? Diet over here, exercise, etc. right? So we keep the diet, the exercise, and all the other factors the same between the groups. And then we're trying to test, does smoking have an effect on heart attacks, right? Getting heart attacks. So does smoking cause more heart attacks, right? So that would be the only way to know, is we have to control all the other factors, or at least the best we can, to be able to compare, right? So this would be an example of a controlled experiment, right? And that would be also true for breast cancer, right? So the same thing would apply. We can't say just because we observe something that it's definitely causing each other, right? When we say causation, we're saying that if someone smokes, this directly causes them to have a higher heart attack rate, right? Or if someone smokes, they will have a lower breast cancer rate, right? Just one thing doesn't guarantee the other, right? And then on the next page, there's one last question involved with this, asking should you smoke, right? And that's really just a personal preference, a personal choice, right? Only you can answer that question, right? So I'll leave that question up to you, right? So I want to walk through just an example here in the homework, just to keep you thinking about this, right? So I have here pulled up a problem from the homework, right? And we're asked some things, and we can click here to pull up the table. So like part A says, what is the chance of a 45-year-old female smoker dying from a heart attack in the next 10 years? Right, so we're asked for female, so we need to pick the chart for women, right? So we'll pull that up. Let me make this full screen, right? So then we need to look for age 45, right? And we're looking for a smoker. So look for age 45, smokers in the bold, right? We want to look at what's their risk of dying from a heart attack. So that's 8, right? So this number, remember, is a rate per 100,000, right? So this would be 8 out of 1,000, right? So we would just click this, and we got it right? Good job, right? So then part B is dealing with a male, right? So first thing I would do is make sure we have the right chart, right? That's going to be important. You don't want to accidentally read the female chart when we're talking about a male, right? So we're looking at a 65-year-old male who has never smoked, is at the greatest risk of dying from which of the following choices over the next 10 years, right? So we're given 4 choices. So we want age 65, never smoked, right? So we can just check these, right? So COPD has a 4, right? Colon cancer is a 6, so that's higher so far. Lung cancer is a 3, so that's lower. And stroke is 9, right? So this would be stroke, right? For someone who's never smoked, age 65, right? So that has the highest risk out of these items, right? So the thing that does have the highest is 55, right? Is heart attack, but heart attack's not on the list, right? So we're saying which one from the list is the highest, right? So we got that, and then lastly, we're looking at a 35-year-old person has never smoked. What are the chances of not dying over the next 10 years, right? So let me go split screen here a moment, right? So I need to I need to make some notes off to the side here, right? One item to note is that if E is some event, that the probability of event E plus the probability of not E, right? So E being true plus E not being true is equal to 1, right? Because either E is true or it's not, right? So if those are the only 2 options, they're probably together. One of them has to happen. They have to be 100%, right? So in other words, an example of this would be like the probability of winning plus the probability of losing, right, would have to equal 1, right? You're either going to win or lose, right? So for example, if it's like a baseball game, you either win or you lose the game, right? There's going to be a winner and a loser. So together, we know that has to equal 1. So if I can calculate one of these, I can find the other by plugging into this equation, right? So this is actually going to be helpful for us in part C because the probability of dying plus the probability of not dying is equal to 1, right? So our table tells us the probability of dying, so we can figure that out. So the probability of not dying is going to be equal to 1 minus the probability of dying. Right, so this is what we need to figure out. Another thing that we need to note is what we call like the classical definition of probability. And that is the probability of E, right, is equal to the number of ways E can occur divided by the total number of possible outcomes. Right? So we'll use this to calculate the probability of dying, right? So we need to figure out the table. So we're doing, this is for a 35-year-old not smoking, right? Never smoked. So if I go for men and look at 35-year-old never smoked, 26 out of 1,000, right? So for men, 26 out of 1,000 is the rate, right? If we look for women, so never smoked, all causes, right, is what I'm looking at, right, altogether, would be 12 out of 1,000. So this is for females, right? So the total number of outcomes, right, possible outcomes would be 2,000, right? There's 2,000 people in this group, if you will, right? So if I put 1,000 men, 1,000 women together, there'd be 2,000 people total, right? And the risk of one of them dying in the next 10 years would be the sum of these, right? So what, 38, right? 38 out of 2,000, right? So if we can carry this on, right? So the probability of not dying is 1 minus this, right? So the probability of not dying, so just plugging this in now, is 1 minus 38 out of 2,000, right? So 1 minus 38 out of 2,000 divided by 2,000 gives me this number, right? So if we look over here, my math lab wants an integer or a simplified fraction. So this cannot be an integer, right? So I need to show this as a simplified fraction, and I get 981 out of 1,000, right? So there's the answer, right? So this is how to work with this chart, right? So I want to do this problem to give us some more practice with that, right? All right, so that's all I have for this worksheet.